Let's go on with the next case, which is about 3D printed hip implants. 3D printing is a very relevant topic right now. Experts, scientists, or operators also call it additive manufacturing. Additive because during 3D printing you add material instead of removing it. Existing procedures are mostly subtractive, meaning that you remove material. An example for that would be the milling process, for example. The case we are looking at is increasingly relevant since the current trends show that a growing number of large companies invest in 3D printing. It could also be a real question for a consulting project, and I have worked on a case quite similar to this one. You could also describe it as a typical operations case, which is either about improving a product or cutting production costs. Often, it is necessary to come up with a whole bundle of measures to solve it. To cut production costs, I would have to take measures in the production process. For example, I could redesign the product or change my supplier. There are many different ideas, but of course, one of them would be to apply a new manufacturing technology for my current product. Once I've come up with some measures and prioritized them, the next step is to validate my ideas with data. And that's what we are going to do now. As you can see already, the case appears quite technical and as if it was made for engineers only. That's right, but I would actually do the same case with non-engineers as well. Of course, the focus would be a little different then. From an engineer, I can expect that he or she knows and is able to use basic technical terms. He or she should also have a broad knowledge about production material or manufacturing processes, for example. For a non-engineer, it is more important to show that you are able to burrow into the manufacturing technology quickly. Today, we will talk about basic technological correlations right from the beginning. On the left, you can see what a hip implant looks like. That's a hip socket, so from below you can see the hip stem in form of a hemisphere. That part is connected with the bone of the leg and pretty heavily loaded actually. So if something goes wrong, for example due to an injury in an accident or a disease such as cancer, the natural hip joint can be damaged and then needs to be replaced by an implant. That's the product we look at today. Here is some data to get a feeling for the dimensions. The left part is 100 millimeters high. The width of the x-axis is 50 millimeters and the depth is 70 millimeters. So this is basically the box I could pack the implant into, the so-called bounding box. The volume of the box is 30 cubic centimeters, just for that piece. One possible question for the case could be, how can I determine the volume when I only have the piece lying in front of me and other than that, no information at all? A good approach would be to use the displacement principle. You could put the piece in a measuring cup and measure how much the fill level of the cup differs. Most of the time that works pretty well. In that context, it is also important to look at the material. Here, titan is used because of its special biological characteristics and because it doesn't trigger reactions in the body, which you really don't want to have. The density is 4.5 per cubic centimeters, and the selling price for which the implant producer sells the implant to doctors and hospitals is 300 euros. Of course, it is important, especially if your knowledge of 3D printing is mostly based on hearsay, to talk about the technology. The technology additive manufacturing, with a clear focus on metal here, is not a completely new technology anymore, but has been used for about 30 years right now. In the last 3 to 5 years, it has been discussed increasingly and been focused on intensively by quite a few players. The question is regularly, can I improve my products with 3D print in any way? On the left side of the slide, you can see a typical 3D printer, such as the Concept Laser M2 Qsing, the EOS M290, Renishaw AM250, Realizer, etc. So there's really a whole variety of machines I can use. They look like existing manufacturing machines, but work a little different. In the figure below, you can see how they function. Let me explain it to you. So there is the platform, which is basically just a metal plate, and there is a piston, which can regulate the level of the plate top and down. When I print something in 3D, the coater runs over the plate from left to right and applies a metal powder, in our case Titan powder, on the metal plate. It's just a very thin layer, and when the layer is applied, the laser is redirected over the powder via the scanner. The powder absorbs the heat of the laser, melts, and merges. So, I basically melted a layer. Once that's finished, the same process starts over again. But I need to pull down the piston one more layer, so the building board is lowered a little. Then, the coater runs over again and applies a layer of powder, which is melted by the laser, directed by the scanner. When I keep melting layer by layer, in the end, a finished product accrues. This procedure has two advantages, and there are two use cases when it really makes sense. During existing processes, I usually need tools or have to write a program for the machine, so the machine can handle my piece after all. For example, when milling. Here, I don't have to do this. I have the possibility to create a component without any tools, just with my CAS data, which means the 3D images. That's always good when I only need a number or a small number of units. When I need big amounts of units or during mass production, the point is to have very fast and productive machines. These machines are usually expensive. For example, during injection molding. That only pays off when I produce numerous units. Here, I don't need any tools, which means I can be relatively profitable with a small number of units as well. The second advantage is that I can melt each layer independently based on my preferences. That enables me to create very complex geometries, which I wasn't able to produce with existing procedures. That's an important aspect to keep in mind. Now, a couple of facts about the procedure. The powder bed coating time to produce one single layer is 10 seconds on average. The given exposure time, so the time the laser needs, is 10 cubic centimeters per hour. Here, the volume is given. What else do I need to consider? We have a layer thickness of 50 micrometers. That's the thickness of the layer the piston can go down to. The dimension of the build chamber, so the size of the platform on which I can produce, is given as well. In our example, it's a machine with 250 millimeters times 250 millimeters times 300 millimeters. And then there is the setup time. Whenever I'm doing a process like this, I need to prepare my machine. That takes about 3 hours per build job. It's given here, but can differ a little in reality. That's the case for all the parameters we are showing here. But I would like to keep using these assumptions for the rest of the case. Now, let's go on with the case. What's been important so far? First of all, I haven't asked a question yet, so up to here it was important that you listened to the case and made sure you understand everything. The facts on the paper should be clear, and you should have asked some questions about the costs of the machines or more details concerning the times. Of course, you could ask that, but when we start getting into too much detail at this point, we won't be able to solve the case in the given time. Let's start with the actual question of the case. Is additive manufacturing and selling hip implants that are printed as 3D prints a lucrative business? Maybe you're wondering, how can I deal with a question like this? What can I do as a first step? The first thought should be that the revenues, so the amount of money you can charge for a hip implant, must cover the costs and should allow a certain margin. That's my ultimate criteria. Revenues must be bigger than costs, plus a certain margin. Now, we know that the sales price of the product is around 300 euros. So the question is, can I offer 3D printed hip implants for 300 euros and cover my costs plus a certain margin? So are my costs smaller than 300 euros? To break it down a little further, the following two questions should be: what are my most important cost drivers? Because when I focus on the costs, there are many cost elements during the manufacturing process that I need to consider. After all, we need to do some calculations to answer the question if additive manufacturing is a lucrative business based on the most important cost drivers. And depending on the answer of question 1, we need to think of measures we can take to improve the profitability of the product.